Hello, math scholars, coming at you with another math lesson. Today it's mostly going to be calculator work, graphing some new shapes we've never heard of before. You want to practice saying hyperbola? Hyperbola, that's the new shape we're going to be exploring today. So make sure you click like and subscribe and hit that bell so you get notifications. Who's excited about hyperbola? Woo! Hyperbola, yeah! All right, so we have a brand new shape to show you about. This year so far, we have studied parabolas. That's if you would slice a cone diagonal, it would make a parabola. Maybe later this year we'll learn about circles if you cut a cone straight across. The one we're doing today is called a hyperbola. So go ahead and jot down what a rational function is. We're going to be studying rational functions the rest of the chapter. But a rational function is when you have an equation on the top and you have an equation on the bottom, and they're being divided by each other. And guess what? Inverse variation equations are rational functions. All right, so we're going to go ahead and graph our first rational function. It is going to be an inverse variation equation, so that's how this is relating to what we learned yesterday. This right here would be an inverse variation relationship, and what would the k value be? 1, right? The 1. So we're going to type it in the calculator and see what it looks like. It's a hyperbola. That's why we learned that new word. So going to y equals, hopefully you all get this graph show no errors. If you do get an error, try a Zoom 6. That fixed a couple people in my last class. Hyperbolas are wild. Look at this. It has 2 branches to it. You're not seeing 2 graphs right now. You're actually seeing one single graph that has 2 branches. Okay? So I'm going to sketch it on my paper. Are the calculators working okay? No errors out in the room? For 0, if you're looking at the table, you're supposed to have an error on 0. Because think about it, if I put a 0 in for x, it would be 1 divided by 0, and that is not possible. Can I borrow somebody's table? Oh, never mind. I have it right here on the paper. So just to check that your table is looking correct, it should start with negative 0.3, go to negative 0.5, then negative 1, and then error, and then 1, 0.5, and 0.3 again. All right, do you even remember what asymptotes are? It's where the graph gets close to but cannot touch or cross. Do you think this hyperbola has any asymptotes? It actually has 2 asymptotes. Isn't that wild? They're both at 0. So one's at the horizontal line, y equals 0, and one is at the vertical line, x equals 0. And just like always, the only thing that will move your asymptote off of 0 is a horizontal or vertical shift. And I think there's only one more thing to talk about, domain and range. So since we have branches of our graphs in quadrant 1 and 3, that means our domain can be positive x values and negative x values. So I'm going to go with all reals, but I need to make one exception. All reals except 0, because that's where that vertical asymptote is. That's the x value I can never touch. What do you think the range would be? Very similar. Same exact thing. All reals except 0, because there's a horizontal asymptote that makes it so I can't touch 0 on the y-axis. I'll go ahead and pause it and answer some questions.
Would you need the negative sign outside?
All right, we're going to go ahead and try another inverse variation equation. This time our constant is a 6 versus a 1. And we mainly want to just compare and contrast what the 6 does to the graph. Does it smush it in? Does it stretch it out? Does it change the domain? Does it move the asymptotes? Things like that. Okay? Now let's pull our calculator and try it. I'm just going to change my 1 to a 6. All right. So I'll go ahead and click my graph. This is where I should have said this first, but you could actually keep that original graph there and graph two at once. Have you guys ever done that? Graph two at once? Yeah, so you can do that. The original one, if you still keep there, is definitely closer to 0, 0. So this one is a little stretched out further. Okay, so stretching out further, the 6 is making these values a little bigger. The asymptotes are still at 0 though, because there's no shifting that's happening. It's just stretching, not shifting. So that means my asymptotes are y equals 0 and x equals 0. Can I borrow someone's table just to fill in the values super quick? Yeah. So it's -2, -3, -6. Again, why do we have that error? You cannot put a 0 in for x because that would be 6 divided by 0. All right, and what do you guys think for domain and range then? All reals except 0 for both. So I'll just go ahead and write that up here. All reals except 0 for both domain and range. And then the asymptotes are the little guys you see in pink over by the graph. Okay? All right, we're going to talk about how you would shift these hyperbolas left, right, and up and down. So we have an equation to write down. I already have it up on the board if you want to look up there. So this equation right here, y equals a over x minus h plus k, where h is your left-right shift. And look, there's a minus sign, just like there always is. So right and left is tricky. It's the opposite from what you would think. And then the plus k is your up-down shift. And so the asymptotes will shift right along with the graph. All right, let's take a peek at this next example. There's no left or right shift, but there is something new we haven't seen before, and that's a negative sign out front. Do you remember how negative signs out front affected, like, parabolas, for example? They flipped them upside down. How do you think a negative sign out front would affect a hyperbola? Yeah, Lexi's going like this. I think she means they're going to switch quadrants. So maybe we'll have a branching quadrant 2 and 4 instead of 1 and 3. Let's graph it in the calculator and look. And we're not going to fill out a table on this one, but we're more interested in the domain, range, and asymptotes. So negative 4 over x. Graph. Awesome. So if you guessed they were switching quadrants, you are absolutely correct. We're in quadrants 2 and 4 now. Do you think those asymptotes will still be at 0 and 0? They still are, because there was no shift. There was just flipping. There was just reflecting. So they kind of stay put. Y equals 0 and x equals 0 are still your two asymptotes. And then do you think that means the domain and the range are still the same as they've always been? Yeah, so they're both all reals except 0. So that one was pretty easy. We're going to look at one that has been shifted a bit. We're ready for it? Okay. It's very important when you go to input an equation this large that you use parentheses around things that are more than one term. So like here, you're going to need that parenthesis to keep that denominator as one group. Does that make sense? So let's go ahead and enter it together so we all enter it correctly. We have all our phones in our book bag every day. All right, let's enter this together so we enter it correctly. 3 divided by parentheses x plus 1. Close that parentheses off, though. Keep that denominator as a group. Plus 2. So before we click graph, can you guys help me predict what will happen? What's going to happen with our left-right shift? That's this guy. Left 1. The minus sign is part of the formula, so reverse what you would think. So left 1, and then up 2. Let me actually just draw that in. My asymptote will go left 1. It used to be at 0. And my asymptote will go up 2. It used to be at 0. So good thing we've got that figured out. Y equals 2, and x equals negative 1. Now let's click graph and see what branches look like. Graph. Over there and up there. Looks like it's crossing at about 1, 2, 3, 4, 5. Maybe here. I don't draw my pictures super accurate, but if you can get like your intercepts at least accurate, it'll make your picture look a little better. And about 2.5. It's crossing about 2.5. Maybe like over here. Yeah.
Really weird. I got that in.
All right, our last question on this one is what is the domain and range? So let's think left, right. It can be all reals except what value on the x-axis will it never touch? This guy right here, because that's where the asymptote is. So domain is all reals except -1. And then range, all reals except what value on the y-axis will we never touch? Good. Two. Yeah. I think I said 2 and wrote 0. Thank you for fixing that. You get a ticket for saving the day. All right. Then we have one last type of hyperbola equation to study a little bit, okay? It's already on the board. It's called ax plus b over cx plus d. Let me find it on my slides. We're ready for the slide to move? Right here. Ax plus b over cx plus d would also make a hyperbola shape. It's a little bit weirder as far as how to find the asymptotes. To find the vertical asymptote, you set your denominator equal to 0 and you solve for x. And for the horizontal asymptote, you just grab the numbers a over c. It's the coefficients, the leading coefficients at the top and the bottom of polynomials. So I did put this on the board. It's not something you would need to memorize. Set your bottom equal to 0, solve for x. That's your vertical. And then for your horizontal asymptote, do a over c. Okay, so we're going to do this one together, and then you'll do the last one on your own as a graduation problem. This is a little bit different format. It is in that format, ax plus b over cx plus d. So we're going to follow that protocol. You're going to set your bottom equal to 0, and you're going to solve it for x. That'll give you your x asymptote, your vertical asymptote. So to solve it, add 16 to both sides, and then divide both sides by -4. So what would that give us? X equals -4. So that would be right here. It's a vertical line. Okay. The horizontal line is even easier to find. You want to take the coefficient of the top, the leading coefficient on the top. It's invisible right now. It's a 1. Ooh. And then you want to take the leading coefficient on the bottom, -4, and just turn a fraction. Grab those numbers and make them a fraction. So the horizontal asymptote is y equals -1/4. You see how I did that? Just grab this number, grab this number. I put my negative sign out front of fractions and not on the bottom. So -1/4 would be located about here. And I do want to talk about how to put this graph in the calculator then, because you're going to want to use parentheses around the top and bottom to kind of group the numerator and group the denominator. So parenthesis on the top, 1x minus 4. You don't even need to type the 1. Don't know why I did that. Divided by, parentheses, -4x minus 16. Yep.
So let's say that x was 2x and the bottom x was 8x.
2 over 8.
I'm sorry. 2 over... let's just pretend that's 2x over 10.
Okay. All right, ta-da! There's my drawing. What do we think the domain's going to be? Or left and right numbers. All reals except who? Good. And then our range, all reals except -1/4. Awesome. So any questions on this one before we do the graduate problem? This stuff's not bad, and you definitely you have the calculator beside you to help you figure out what the picture looks like. So it's just coming up with those asymptotes and the domain and range, of course. All right, let me find a good last problem for a graduation problem. Oh, you want me to go back? Okay. No, that was the one we did together. This is your graduation problem. So I'll pause the video, let you try it, and then I'll put the answer up and say ta-da, and then give you the homework, okay? Ta-da. All right, ta-da! Here's all the answers. We said our bottom equal to 0, figured out that x equals -3 was our vertical asymptote. We did our a over c, which is 1 over 2 for a horizontal asymptote. And then you can see my domain was all reals except -3, and range was all reals except -1/2. Now your homework tonight are these problems out of your book. So thanks for watching.